Okay, this I'm introducing two words: magnification, magnifying power. Magnification can be linear, can be like a transverse, can be lateral. It can be no. What about magnifying the overall dimension of object 10 times, 20 times, 40 times? I think now we have mobile, no? Nowadays good mobiles are there. They say like a 4 into 6 into 8 into zoom, no? Am I right? You can magnify, no? That particular thing. How do we magnify? Yes, by changing the position of lens there. Inside that what happen, the lens what happen can be moved away or that one. It can be shifted. Inside the mobile weapon, it can be shifted. By changing that position weapon, we can control the zoom. What do you mean by 4 into zoom? The same object will appear 4 times bigger. 6 into zoom, 6 times bigger. 8 into zoom. If you purchase the Canon digital cameras, 24 into zoom, a given object weapon, 24 times it will appear bigger. Got the idea? So there's the thing. So how do that magnifying power, how to change that one, on what factor depends. That is what we are going to study here. What is the basic necessity of this particular equipments? To see things clearly. What all we have objects, no? I want to see objects around us clearly. Suppose a moon. Okay, let's see with our eyes. What we see moon, just some white disk, no? And some shades, some here and there, some few shades. That's all, no, the moon. And we say there's a mountain, something, one tree is there, under that tree one lady is sitting. Are you able to see? Like that they tell stories. But once telescope came, what happened? There's no tree, no lady, only mountains are there. But I know that when I was childhood, no, they used to tell stories like that. They used to show moon. There one, you can see there one mountain. We used to say, okay, we see one tree is there. Since elders used to tell, okay, we used to say, yes, our tree is there. One lady is sitting, not visible. No, you are kid, no, not visible. We used to listen that stories. Okay, then finally, when I came to high school, no, then our physics teacher shown telescope. Then very first question I asked, like, I want to see tree and one lady sitting in moon. Then physics teacher showed me. He took me to his home. Then night, what when full moon day, okay, we can see clearly, no. Then there's no tree, no lady. I was really shocked. That's what telescope. See, now we'll get information. Scientific information will be available in our hand. We can see clearly things. So now we have a telescope where we can count Saturn rings. It will cost you 4,000 rupees, are not big. Telescopes, Newtonian telescope, reflective telescope, it will start from 4,500 rupees. You purchase that. Saturn rings you can count. You can see satellites of most of the planets. Very beautiful. The sky, what will happen? You don't get sleep if you purchase telescope. That much I can say. And you just go purchase telescope. Okay, that stand also, tripod they will give. You go to the terrace, take one black blanket, cover yourself, because the other light should not enter into telescope here, your eyes. Only the light that is entering into telescope should enter into eyes. So cover with a blanket, sit there. And if it's it's far better, just go outskirts of Hyderabad, some 50, 60 kilometers, so that the light coming from the city lights, everything what happen, will not diminish the image. 50, 60 kilometers, go outside, sit there, open terrace, so snakes are there. Okay, make yourself safe, sit there and start watching. If you watch, no, around you, what happen, there will be some 28, like a group of stars will be there. Each group again contains many stars, like this one. First you'll see this one. There's a very beautiful thing what you can see. Like this, how many? 28. 28 group of stars. In each, again, this cluster of stars, what happen? There'll be many other. Some will be 5, 6, 7, 8. What will be that number? Like that, 28 clusters you can see. Each cluster, 6 to 9 stars will be there. And each and every day, the moon will be near to one star. Like this, the moon will come. Next day again you check it, no, the moon will be here. So if you purchase the telescope, no, so you can request that particular manual how to use telescope. They'll say that. I think you should know the Dhruva star, the northern hemisphere, hemisphere star we call. So in scripture they'll call it Dhruv Nakshatra. There is a reference for us. That one. So that will, they're always lying to the north. It will not. It will never change its position. We don't know the reason. The science is unable to explain. But in scriptures they are given reason why it will not change its position. So there's a reference for us. So with the help of that, what happen? You can identify this cluster of stars. Then each and every day, what happen? You can see moon will be there nearby that. That's why you look at the calendar. No, we have 28 days Hindu calendar, and each day. Today is Mula Nakshatra. Am I right? So look at the moon. The moon will be near to the Mula Nakshatra. Yesterday it was like a Aslesha Nakshatra. So that particular cluster of stars, they given name. That one. So you can see that 28, what we have 28, 20 will be there. Every again the after 20 days again the moon will come to, suppose that today the Mula Nakshatra is this a Mula Nakshatra. After 20 days again the moon will be there only. So what all we have a calendar, no, it's based on science available. Based on what? Based on the earth reference. And what all we learn science based on the sun as reference. There is only difference here, nothing big. What all calendar we have, no, is based on what? The earth is reference. You stand on the earth, then you see all objects revolving, the total universe revolving around you. They took, since we are on earth, they took earth as reference, then they explained everything, the planetary position, everything. And if you stand on the earth here, no, you can see the planets revolving around you like this in different positions. Jupiter, Saturn, Mercury, like this, they'll come. So even the moon is considered planet, sun is considered planet, and we have 7 planets. The remaining 2, actually we say 8, no, nowadays the 1 is removed. So that we say Navagraha like that. And you can see daily their positions, they'll be revolving. So even the sun revolves around the earth. That's why you see morning where is on the eastern side, no? On the evening, you'll be there on western side. Who is revolving? Earth is revolving around sun is revolving around it. You stand on the earth, sun revolves around the earth. That particular reference earth they've taken and they designed a calendar, Vedic calendar. Huh? The things are very systematic. It's also systematic science. But don't ask me, sir, Navagraha Puja. I don't know that. I don't have knowledge to explain that higher spiritual science. But at least the calendar is there based on science. So if you are interested, purchase telescope and see the beautiful world. Definitely I can say that the night, what happened is more beautiful than day. If you have a telescope, that one, do watch. Okay, let's come back. That one. What is the basic necessity? I want to see the moon, inside the moon, a tree and a lady sitting. But how to, if anybody tells stories, okay, just we have to listen. With the telescope, we can watch and we can claim whether really that tree and lady is there or not. So now what is the requirement of the telescope? What it should do? The object which is far away, its image, or it should bring moon near to us. Okay, so this is a earth. Okay, I have a telescope. I'm just giving general description, and this is a moon. Huh? Oh, that one. So I'm here. Tell me what this telescope should do. Will it bring the moon near to me so that I can see things clearly? After seeing again, this telescope will send back the moon. Should it do like that? The instrument? I think we don't have such instrument, no. So what this telescope should do, at least what happens if it can bring its image near to me, I think problem solved, no. If it brings image, so what is this? This is an image. This is a real moon. So this telescope, if it form the image of the distant object near to me, now what happened? What will be visible? So both are visible? No, only this image will be visible. If I close this telescope, then this will be visible. If I see through telescope, then this image will be visible. This image is brought. What is the radius of the moon? I think something around 2000, so like around 8,000 kilometers. What about this? This will be of order 4 centimeter. But that is enough. Huh? You just do one thing. Draw a disk of 4 centimeter, keep it nearby your eye and put some dots or draw anything. You are able to see clearly. That is enough. So the image of the moon, what pen will be brought near to the eye. And the eye is able to see things clearly a little bit. That's what the telescope should do. The same thing in the microscope. A tiny microscope, tiny virus. So it will magnify it. There's a tiny virus. Then it will magnify it. I'm able to see now, okay, virus to eyes, nose, lips, everything. I can say like that. If I magnify it. If it is not magnified, then I'm not able to say, oh, sir, what about the lips? I'm unable to see here. After magnifying, I'm able to say it's having a lips. So what this instrument should do, it should form image of the real object near to the eye so that we can have a clarity of the image and we can study the image here. So that's the basic requirement here. For that, let's talk about our eye, human eye. So what that human eye? So human eye is how the human eye we are able to process the image. Tomorrow I'll discuss the human eye, that one, because not part of syllabus. Just we'll have some basic picture tomorrow, that one. So if we start with the human eye. So inside what will happen, it will have a lens. Then this is called like a retina, no? Or what you can call virtually screen. And the object is kept far away. Or let it be tiny. So this is the object. Just wait. I'll have water. Okay, this is about the. Can you hear me clearly?
Yes, sir.
Okay, that one. Some power has come. No, we'll get into this. So this eye. So I'll keep object here. Height of the object is h naught. There's a lens. So where that image should be formed here only. So shall we take this is object distance. This lens, there's a lens, and the distance from the and this retina or screen little bit. So first what happen, the ray of light will come from here. It will bend it. So then here is what that image will get it. So a rough diagram it is. The image will be like this, will not be straight. The image what pen will be formed and retina will be like not a screen, flat screen. It will be a curved screen. I think all of you know the human eye. The retina will be like the screen will be curved, that one. So this is what the image H1 will be formed. Then according to the optics, let's go for it. 1 by V minus 1 by U1, 1 by F. So this should become equal to 1 by V. What is fixed here? 1 by V plus 1 by U1, 1 by F1. Why negative? I think object distance, these are the direction of incident rays. After refraction, it will form an image here. Now, what is the biggest problem? The distance from the lens and retina or the screen, the retina part will be fixed, no? Or anybody can change this distance? Not possible. This V is a fixed here. There's a major problem in the eye. Now, as I vary the object distance, tell me what should change according to the formula. As I vary the object distance, the focal length of the lens will change. Now, when the object is nearby it, okay, so it will form an image. So now I'll start moving this object further. I'll start moving this object further. And the object is kept further from the eye. The same object, maybe the dimensions a little bit appear like this. So what will happen to this lens? This lens again will accommodate, will form its image. But here if you look at the ray, it will bend. And the image formed will be small, that one. So this is H2 and this is V, this is F2 and this is U2. This is an object. Okay, agree this. So again, what is the formula? The formula will be 1 by V plus 1 by U2 equal to 1 by F2. Okay, from the very clear, you look at the mountain. I think nowadays we do photography, we hold the Taj Mahal. Can you hold Taj Mahal? You go nearby it, can you hold it? But in photograph, they hold Taj Mahal, no? How it is possible? What is the problem there? So actually, you look at the mountain. I think most of you are sitting at home. You try to view the far away objects in your room. You can view comfortably, Then the same, and you start moving near to the object. As you start moving near to the object, then what happens? The same object appears bigger, no? Is it okay? So is it object size changed or our perception of viewing has changed? You have to answer this. Means mountain is there. If you move away, it will become small. And as you move towards it, the mountain will become big. So is it really mountain changes or our perception is changing that one? Our perception of viewing has changed here. So why do the objects which are far away, they appear smaller? The reason is this particular thing. The optics is what it tells that one. The height of the object is same, h0 say 10 centimeter, 10 centimeter. But the height of the image formed by the eye, h2 is less than h1. h0 is same. h0 is how much? Say like a 10 centimeter, 10 centimeter. What is h1 here? It's, let it be say 2 centimeter, 0.1 centimeter. So why do it has happened? Because this was the accommodation eye. So tell me like where it will be more comfortable. This is eye, huh? Where you'll be more comfortable. I'll ask you to go and in your room, no, just if you have window, everything, just come outside and try to see far away buildings or trees. I'll ask you to view it for 1 hour. Yes, you can view it comfortably. But the same object now, the same building, as you far away object now, you start moving towards it and you bring it nearer. Means what is the least distance at which you can view it? So as you bring it near to the eye, what happens? The lens has to bend, the rays has to be bent more, no? But who should do? The lens. See, if they're far away, it can bend the rays very easily. Am I right? If it as the object comes near to the eye, what happens? The lens, what happens? It should bend the rays more, no? To accommodate that image. It should bend the rays more. No, further you move the object, the rays will bend. Further you move the rays will bend. There's some limit, no? And as it starts bending the rays, what happens? The focal length has to change. Because as you move this, as you change the object distance, the focal length has to change. How the focal length has to change? Here the muscles will be there. So what is this lens? Again, the human lens, it is made up of 3 layers. One, this will be a soft liquid will be there. This will be again one more layer, again one more layer. So this outer layer, what happen will change its shape. And according to lens formula, if R1, R2 changes, even the mu also variable. Again, the three different mu's will be there. That mu proportional will change. Like that, what happen? The human eye always will try its level best to accommodate the image. So as you bring the object more nearer and nearer, so what happens? The focal length of this should be such that what happens? It should bend the rays more. For this particular thing, what happens? The lens, what happens, will be strained. It will become bulged like this because to accommodate that image. So when object is far away, it will be almost in its natural position. So who will change the shape of lens like this? The muscles here, ciliary muscles they call it. They will bend it. They will change the shape of this lens, and the muscles will be in contraction. So now you do one thing, all of you, take pen or pencil, keep nearby your eye and try to weave it. All of you can try it, or take your mobile, take it very close, almost 1 or 2 centimeter. Try to see, try to weave it for 1 or 2 minutes. All of you try it, because what I'm telling you should, you can feel it now. Keep it mobile near to the eye at a distance of 1 or 2 centimeter. 1 or 2 centimeter. What I mean to say is like this. If there's a mobile, no, keep it like this. And move it away, and also try to bring it. And now try to see the diagram which I drawn, and you start moving it away. Tell me anything is happening to you. Just do once so that it'll be easy for me, because instead of giving speech, no, you can really feel that what I mean to say. Tell me like, let it be far away like this. Let it be that one. Don't take selfie. I'm asking you to make observation here. So it is like this. Then as you bring here, I'm able to see it. I'm able to see it. Then what happened? Now I'm struggling. I'm unable to weave it. I'm unable to weave it. So like this, let me watch for 1 or 2 minutes. You try to do this one. Anybody getting pain? You get very good pain, no? What's happened? The muscles in the eye, what happen? They'll try a lot to adjust the focal length to bend particular rays. And what happen? We are unable to weave it. So as the object appears near to the eye, the lens in the eye fails to accommodate the image. The lens in the eye fails to accommodate the image. And at certain distance, what happen? We cannot recognize the object properly. So you can say some strain in the eye. For this, so tell me like which one will, when we can see the object comfortably, if it is very near to the eye or little bit some distance away from the eye. If it is away from the eye, agreed all of you? If it comes very near to the eye, as we are unable to see it properly, and lot of strain will be there. So then what is the least distance at which we can see the image comfortably? 25 centimeter. For a small kids, infant kids, it is around 8 centimeter. As you grow old, after 5-6 years, no, then it will come to 25 centimeter. So what is the least distance? So I'll come to the next part. So the distance of least distance of distinct vision. Least distance of distinct vision. What do you mean by distinct? Means with comfortably, clearly. I should not use word clear. Distinct means as you are able to say that it's an object. That's called a distinct. Least distance of distinct vision. What is the value of this? 25 centimeter. If an object is at a distance less than 25 centimeter from the eye, the eye will get strained and we are unable to see the object clearly. Am I right? I think as you bring your mobile near to the eye, no, you are unable to see. You can't say, I'll ask you what I wrote here, lens, F1, F2, you are unable to see. And as you start moving away, yes, once the object, your mobile is at a distance more than 25 centimeter, you are able to see things clearly. Then if it is far away, again, it's a big problem now. You do one thing, mobile, keep it some nearby adjacent wall. You stand at other wall. Can you see this diagrams all? Not possible, no? Anything, what happened? You can see comfortably. Keep mobile at a distance of 2 or 3 meters and try to watch it. What all I have displayed, no? Try to watch it. You can't see things clearly. Any reason? because object is far away. So what is the problem now? If object is far away, we don't have exact information of the object. The eye cannot clearly, you can say that one, cannot resolve it properly. Shall I use word resolve? Say keep mobile far away, means at adjacent wall. Try to see. Can you read all these things? Not possible. What is the reason? The eye is unable to resolve. So if the object is far away, we can view it comfortably. If object far away, we can view comfortably. But what is the problem? The clarity of image, or can say the resolution is the problem. We are unable to resolve it. You are unable to read. That's called resolving. You are unable to resolve. R-E-S-O-L-V, resolve. We are unable to resolve. Then what is another problem? If object is brought very near to the eye at a distance less than 25 centimeter, what is the problem? A strain will be there. So tell me, like, the image formed, what I should do? The image form should be such that I should able to resolve, and also when there should not be strain in heights. So therefore, what is the minimum distance shall I put for the image formed by an instrument? It should be at a distance at least greater than or equal to 25 centimeters. This is the minimum distance. The image formed by the equipment should not be at a distance less than 25 centimeters. This is a condition. Sir, but even at 10 centimeter, I can see clearly. That is your good eyes. You are having good eyes. But on an average, 25 centimeter for the total world population, they have put it. Since you have very good eyes and you got 10 centimeter, means don't change the numerical data. I don't know. Some of students like at 10 centimeters, I change. I'm able to see. So in exams, I'll change it. So let's follow the scientific data, average scientific data. So this is the distance. So what is the condition for the equipment? You should form image at a distance, what the minimum distance for pen? 25 centimeters. Anything greater than that, no problem. But minimum distance should not be less than 25 centimeters. This is the one condition for the equipment. Is it okay now? Then what is another thing? What we have seen, if the object is far away, the eye is able to see it, but may not be clearly, but comfortable, no? So shall I make a compromise both? So what type of instrument I should bring? I should design an instrument such that the image of an object far away, means the object which is far away, its image should be brought near to the eye, and where it should be at a distance greater than 25 centimeters. Then I think we'll be in a better position. So what conditions shall we put for our equipment? The equipment, the telescope or microscope, what I'm using, what it should do? The object which is far away, its image should be brought near to the eye so that I can see things. Then what is the another condition? It should be at least at a distance of more than 25 centimeter. Like this, I should design it. This is called as the accommodation of eye. So now I can put it, I can view because the muscles need not be under strain. Then naturally we are able to see it. So next again, what is this? This eye is strained. We brought here. So that's why they suggest no, don't read putting your face into the book. At least minimum 25 centimeter you have to maintain. There's a requirement. Either mobile or television, whatever you keep it, no, it should be that one. Some of the telex are lot of strain in eyes. Why lot of strain? Is because you have kept mobile at a distance less than 25 centimeter. Okay, now you know a little bit of optics. Do follow. Take help of science. You'll be in comfortable position. You can minimize the strain in the eyes. Okay, first thing. Okay, this one. Next, I'll introduce magnifying power. Tell me, like, here the core idea of this one, magnifying power. Tell me, like, why you are able to see here clearly, no? And you are able to see, you are unable to see things clearly. So as I move this object, shall I say angle subtended by the object at the eye will increase? Angle subtended. So this angle you can see, no? This angle, so some. I'm slowly introducing the important part here. I should show with respect to center of eye. Let me show like this, so it'll be easy for you. And now look at this angle, theta 1, theta 2, which will be greater. theta 1 greater than theta 2. So when you can see object clearly, if the object subtends more angle at the eye, and what about here? Though it's far away, what is the angle subtended by the object at the eye? It is less, no? So therefore, what is one more requirement of the instrument? The object which is far away, which the eye is unable to see it clearly. So what that instrument should do, it should bring the image of that object near to the eye. If that image is brought, so what happens? It can subtend more angle that image, then we are able to see it clearly. And at the same time also, the image formed by the equipment should be such that it should be at a distance more than 25 centimeters, so that the eye should not be strained. Why do the strain will come? Because the muscles which are here, they should press this lens hard so that its focal length should change in such a way that it should accommodate the image. And these muscles get strained. That's why we'll get a pain in eyes. This is the reason. So this okay, no, this angle subtended. So now this one. So what is the basic requirement? It should subtend more angle, no? The image, if the object subtends more angle, then we are able to see clearly. So I'll define now the magnifying power. I think